Retrieval Augmented Generation. This is what that process represents. It's really the idea where you've got this unstructured data, multimodal data. It could be some things like PDFs or videos, audio files, right? But the idea is with RAG is the ability to tap into that unstructured data and be able to garner insights. Very often where people are using AI today, where they're going to be doing things like this, might be in like ChatGPT, Gemini, where maybe you literally will upload, a PDF, and then you might ask questions about it, right? And so RAG, that whole process that supports that is what RAG is. So you've got your unstructured data, and there's an ingestion and inference portion of that workflow where the ingestion, you take that unstructured data, you load it, extracting out that raw text. If it's like a video, things along those lines, and you need to kind of transcribe that video into text. From there, you chunk that text into smaller chunks. You embed it using an embedding model where it's stored in a vector database. So that's your ingestion of unstructured data. Now, the inference portion is that you've got your vector database here with all of that unstructured data. But then the user in that interface will ask a question in natural language that also gets vector embedded, and it'll be bumped up and doing a vector similarity search against that data that's been ingested. And that's where the answers come back, and you will use an LLM to then provide an answer in natural language. So that end to end, that's what RAG represents. Okay. And again, this is all sort of obfuscated, where if you're using things like Gemini, ChatGPT, it just does it. But that's what's happening behind the scenes. So, but when we talk about AI data pipelines, this one-off interaction with a chat interface, that's great, but it doesn't really scale, right? And companies today have a plethora of unstructured data. All of the things that I just talked about, video transcripts. I mean, right now, this meeting is being transcribed, right? It could be something that you might want to use in the future. And these are the types of things that companies are now thinking about with the advent of AI. So it's more than just agents, but it's about interjecting this AI feature or these AI capabilities in the data pipeline, so you get more insights out of data that you didn't realize you could in the past, or maybe it just seemed too, daunting to actually do that. So that's kind of what this looks like. It's like you've got this pile as a company, you've got all of that unstructured data. You want to do that RAG process so you can get all these insights. But in reality, when you go to do that RAG in the real world at scale, it can get really complex, right? I'm sure everyone here is very familiar with these types of things where you've got all these different data silos. So you've got all of your data all over the place. You're going to have all sorts of different things in your ingestion pipeline, but without going in detail, what this really represents is the complexity of RAG at scale for a company. But if that kind of level setting with RAG kind of makes sense, what we'll do is go into this tale of two pipelines. So this is a little bit of a story I wanted to tell you, okay? I'm going to start here. So here's a use case. I started to build out some pipelines because of what I wanted to show from a Matillion lens is how we do RAG, okay? And so the use case that I worked on was analyzing competitor financials. So what I specifically did is I went out to the Lyft and Uber websites where they have posted all of their quarterly financial reports. I downloaded all of them. So for 2024 and Q1 of 2025 and Q2 of 2025 as well. So we've got 12 financial reports in total. And they're all PDF format, and I put them into an S3 bucket. The other thing I did was I prepared a set of 18 questions that are financial in nature that kind of represented the types of things that, wearing my financial analyst hat, that a financial analyst might actually want to know about every financial report that maybe they're reviewing. So here's an example of some of these questions. I want you to get a sense of what those questions are like. So things like, what were the total gross bookings for the quarter and what was the year-over-year growth? Or what was the net income or loss for the quarter? So these types of questions are very specific about in the PDF, what are the numbers, right, that are being posted about these specific kind of metrics. But there's also other questions here that are not nearly as specific. Things like what factors did the CFO attribute to the financial performance? Did management discuss any specific initiatives related to improving customer experience or market share? So what you're getting a sense there, it's more of an inference, right? It's not about give me a number, but give me the, what is going on here from this lens. So these are really important insights, but if you think about this, without a RAG workflow, how would you have attacked that in past lives or in these legacy patterns? Pretty challenging. But you're going to see here how we can do it and what RAG looks like that allows for these types of insights using Matillion. So with Matillion, if you're familiar with Matillion, with our low-code platform, we've got components that allow you to just interject all sorts of different things like different sources. But what I'm focusing on here today is all of our different AI components. So I like to think of it as choose your own AI because what you're going to be able to do in the Matillion platform with our low code ability, right? It's really drag and drop of different components. And what you're seeing here is a representation of all the various AI focused components that we have on our platform. Everything from like in here, these are all related to RAG that we're talking about today. Different vector stores, Postgres, OpenSearch, Pinecone, Snowflake, right? All sorts of different AI prompt components where you might integrate to do LLM integrations, things like Google Vertex, Amazon Bedrock, Azure OpenAI. You kind of get a sense here. And all these different AI utilities, things that are going to allow you to deal with those multimodal sources, Amazon Textract, Document Intelligence, Speech Transcribe. We're going to be adding more as well. But what you can see here is that with these suite of components, we're really going to be able to help deal with all of that multimodal data and work them into a RAG workflow. So with that in mind, I went ahead and did this myself. I built this pipeline, and this is just kind of what it looks like. This is the main core of it. This is what a RAG pipeline looks like in Data Productivity Cloud. Now, if I were to walk you through these steps, I've got my files in an S3 bucket. This first step right here is just going to copy them into a Snowflake internal stage because what you're going to see here is that this is all powered by Snowflake Cortex. So you saw in the prior slide where we've got a lot of different AI components. When I built this out by hand, so Maya has not been interjected yet. I'm going to get up to that, but I built this by hand. And I decided I want to use all Snowflake Cortex native features. So copy to internal stage. Got a step here where we're using Cortex to take that PDF, extract the raw text, and load that into a table, do the chunking of the data, embed that, and storing that into a vector database, which is also Snowflake, and then doing those financial analysis. So that's kind of the high level, but let's dig into it a little bit deeper, okay? So here is kind of where I'm really going into that live demo. I'm going to be just flipping back and forth between the slides and my pipelines here. Now, as we kind of dig into it, let me just show you a little bit more detail here. Okay, so if I go in here, this is the one where the pipeline's actually doing extracting the text, right, out of the PDF. So here's my Cortex parse document component. Pointing at an internal stage, I've got a variable saying that's dynamically defining what the file is that I'm processing. I'm doing OCR mode. So with OCR, that's exactly it. Take the PDF, it could be an image, extract the text out of it. That's what's happening in that step, okay? Now, on the next step, as I kind of mentioned in here, is that now that I've got it all in a raw, now I'm doing chunking. And I'm going to talk about this for a brief moment because this whole idea of chunking, if you're not familiar with it, is really important in RAG. Now, a lot of data engineers, data scientists that might be doing RAG on their own, they're going to spend a lot of time developing the actual code behind doing the chunking. And that's really the beauty of the Matillion platform, right? Is that we've got these out-of-the-box components so that as a data engineer, you don't have to worry about how do I chunk or the code behind the chunking, but you can actually focus more on the things, the knobs and dials, the configurations that you would normally do. So if you're familiar with chunking, the main things that you're going to think about are, well, what is the text? Like, what is that raw text represent? So very commonly in this case, it's just a text format. And then the chunking method is, and so if you chose a different format, you might have other chunking methods, but what's a really common pattern is this recursive character splitting, okay? That's a really common chunking method. What I would say is going back to my earlier comment, a lot of data engineers might be trying to write some Python to do recursive character splitting, things like that. You don't have to worry about it. It's a drop down. You just choose it. And when you do this chunking, the other thing that you're often kind of tweaking, doing some trial and error around is the chunk size, which is the number of characters, and the chunk overlap. Because what you want to do is you want to chunk up that raw text so that you've got some context in it, but it's not too big, okay? But you want some overlap so that your different chunks kind of have, it helps with similarity search is basically the way I would explain it. But this is something, these values are things that you would iterate on, do some trial and error to see the quality of the results you're getting. But what you're seeing here is the ability to just very easily focus on these values rather than the underlying logic. These separators are related to recursive character splitting. This is basically saying, and it's hierarchical, but basically splitting on, and a paragraph and a sentence in different characters, words, spaces, things along those lines. But what you're seeing here, these are the main things that you would configure when you're doing that chunking, and how to chunk that raw text, and it's going to be stored into a table. From that point, you're just going to embed it, okay? And so you've got that raw chunked data, and then you're going to use Cortex to embed it using an embedding model. Here I'm using Snowflake Arctic. And so what that embedding is going to do is using that embedding model, it's going to take that chunk of text and turn it into its numerical vertical, the numerical um, vector representation of that data. Going back, at that point, that's the ingestion, going back to the diagram I had earlier. This next step right here is the inference step, okay? And again, a little bit of a demo, but it's representative. But what you're going to see here is this is how inference works once you've done the ingestion. And what I've done here is I mentioned I have 18 financial analyst questions. So if I were to just look in here, I've kind of got them manually defined in here. I'm going to go to this mode because it's easier to read. So you can see here I've got my 18 different questions. They're actually categorized, but you can see like they're the ones that I showed in the slide earlier. Okay. But what's actually happening here is if you follow along, this is my vector embedded raw financial report that's been chunked and all of that. Here's my raw questions. I need to embed that as well, because once I have both of those embedded, I can use a vector similarity search. This is where the question is then bumped up against the incoming data, and you can say what type of similarity function you're going to use. I'm using cosine similarity. So going back to it, this is the stuff that you're probably going to want to configure. It's like, well, what type of similarity function am I going to use? And what is my top K? What is the number of results that I want to do something with? Because at this point, when this output is just kind of raw chunks of data that and ranked based upon how close it was to the question. But based upon that, that's being fed into a Cortex multi-prompt. This is using Cortex Complete, and I'm using the Claude 3.5 Sonnet model. But with Cortex, you've got a lot of other models you can use, okay? So I'm just using 3.5 Sonnet. But the idea here is I've got all of this incoming, the question, the category, the actual chunk data that was the response, okay? And here's the context I'm giving this. You're a financial analyst, okay? And in the outputs, what I want is what is that actual in natural language? What is the summary of the answer to the question? Um, Also, there's an answer available one. That's actually important because I do have 18 standard questions, but not every question is going to be able to be answered. So I wanted a true or false there as well. Okay. So wanted to set the stage. I've gone into a bit of a depth here, and I'm not going to go as far as deep in some of the other parts, but I want everyone here to understand just kind of how that all works. But here, what you can see, just to give everyone a little bit of that insight, I want you to see what some of this raw data now looks like, right? And this is the beauty of the Matillion platform, right? Just the ability to look at your data directly in your pipelines. So here, as I sample it, these are all of my chunked or parsed documents, I'm sorry. And so for instance, this is the 2024 Q1 Lyft financial report. That was a PDF. It's been extracted as full raw text. You can see here the page count was 11 pages. Okay. This is what it looks like after that data has been chunked. Okay. So just using that with the chunking and so with the overlaps and all of that. But you can see here now I've kind of started to break it out into smaller rows. So now I've got 700 rows of data. What it looks like after it's been vector embedded, the numeric vectors, right? That's what you're going to see here as it comes up. Okay, so yeah, so here's my chunk data, that raw chunk data, but after it's been vector embedded, that's what that looks like, okay? And that's what's stored in that vector database. And once it's stored like that, here's where that financial analysis has happened. In fact, I want to filter on the ones that I was able to answer because I want you to see kind of the end result. So, against those 12 financial reports, 18 questions, I was able to get actually 60 answers out of all of those. Okay, so as an example, for fiscal year 25 Q1 for Lyft, with the category of non-GAAP reconciliations and definitions, here's the question. How does the company define free cash flow? And so here is the actual AI generated response. It's defined as a management measure used to evaluate operating performance and trends. But again, this is based upon what was stated in the financial report. Let's see if we can find one that's actually a little bit more interesting. What was the total revenue? So one of those numeric ones, right? And so you can see here, it was able to pull this out. Okay. So that's kind of what RAG looks like. Okay. And that's what it looks like to interject AI into a data pipeline. And you can do it at scale with Matillion. We've got all of your different connectors, source your data from all of those data silos, be it on-prem, SaaS, what have you. Now, I haven't interjected Maya yet. Talked about this pipeline that I built. I built it by hand. Took me, I would say a couple of days as I was iterating and testing things out. And I felt really good at the end of the day when I had it all complete. But this is where Maya comes into play. So I did that, and I did it a little while ago, but more recently, just kind of where I started with choose your own AI. Matillion, we've got all of these different AI capabilities, and I built this one pipeline that just shows us tapping into Snowflake Cortex. So I wanted to build the equivalent pipeline, but using other AI components. So here is where I actually leveraged Maya. I simply said to Maya, I'd like to copy these pipelines and use them to make a version that uses AWS native components instead. That was my prompt to Maya. Okay. Now, Maya went off and did it. It was a collaboration. It wasn't a one shot where I just said, go do it, and it went and did it. There was definitely some conversation in a Maya session between myself and Maya, but at the end of the day, Maya did everything I needed it to do. What it did was it swapped out for the text extraction instead of the Snowflake Cortex. It's going to use Amazon Textract. And for the vector embedding, instead of using that Snowflake Arctic model, it's going to use the AWS Bedrock Titan model. Ultimately, this is what that Maya generated pipeline now looks like. Now let me go into that. What's really cool about the Maya generated pipeline is that I mentioned with the Snowflake Cortex one, took me a couple days to build, and I felt really good about that, to be honest. This pipeline that I had Maya building in collaboration, I was testing it about an hour into my session with Maya. It already been built out, and we were testing everything. Okay. You can see here, this is where it was using, and if I go to actually, this is where I can sample, but I want you to see the actual pipeline. But you can see in here where Maya's and all these notes that were created, this is all done by Maya, but here it swapped out this Amazon textract to do the exact same thing to extract that raw text from the PDF. Down here is where it swapped in the AWS vector upsert, where if you could see in here, you can actually choose other embedding providers, but because I asked for Amazon or AWS, it chose Bedrock. And that's where I'm using this embedding model, okay? Now, without going into the same depth as I just did, this is doing the exact same thing, okay? But you can actually see, if I were to sample the data, you'll get very similar data, okay? So here, this is the Amazon textract extractive. So it looks different, as you can see here, than doing Cortex, but it's doing the exact same thing, okay? And even if I go all the way over here to the financial analysis that was done based upon the AWS extracted, what you're going to see here is, notice, remember with the Snowflake Cortex, I had 60. Here I've got actually 84. So I actually had a little bit more coverage on my questions. And so you, again, with the question and the answers, we can actually take a look at some of these, the answers that we're getting. All pretty cool, right? So I had a session with Maya, and I was literally an hour and a half into it, and I had this all done. Now, if I go back to when I built everything with the Snowflake Cortex, I was a couple of days into it, and I felt really good about being done after a couple of days. But when I was done with that after a couple of days, I moved on to the next thing. Here, I was an hour and a half into it. I was already tested. It all looked great. Well, that's where I wanted to leverage Maya a little bit further. And honestly, in a pre-Maya world, I probably would not have gone to this level of depth. Okay. And this is where my tale of two pipelines really comes in, because then I said to Maya, this is exactly from my session with Maya. I've run both of those pipelines, so all the data has been loaded. Can you compare the financial analysis results of the Snowflake Cortex generated data versus the AWS native one and summarize what you find? If you need to create any new pipelines, I'm just giving Maya the direction of like, hey, if you're going to create some stuff, put it in a specific area. Specifically, I was like, this was not my question going into it, but now that it was done and seeing the 84 versus the 60, I'm curious if all the same insights are being found using both methods, right? And so that was a really interesting thing because like now I'm partnering with Maya to really do some more data analysis. And what you're seeing here is that Maya generated this report for me. As you can see here, it's all in Markdown, so it's very pretty to look at. And this is that Snowflake Cortex versus AWS native comparison. Now, I'm not going to go into a lot of detail, but I'm going to pick out a few things that you're going to see here. The cortex, and I think this was based upon just a slightly different set of data. So instead of 60 was 61. But you can see here, it's exactly what I just kind of called out. That in Cortex, it was able to answer around 60 to 61, but with the AWS, it was able to answer 84. Okay. And in fact, you're going to see some of these other metrics, and it goes into a lot of depth. It was really, really fascinating, is what I would say. Okay. And if I were to show you this, okay, this is where it is. All of these numbers and metrics that it was pulling out are backed up by these pipelines that it built. That's how Maya was able to build this report, and it all did it for me in minutes, literally. And I was analyzing that report, okay. And what you can see here is just as I've been doing, I could sample along the way, see the logic that Maya built out to generate this evaluation. Now, when we talk about this coverage of Cortex having 61 and AWS native having 84, one of the things that I would actually mention, it's not that one is better than the other. It really actually, at the end of the day, had to do with the embedding models. The embedding model I used in AWS was a little bit more robust, had supported more dimensions, which ultimately is where this delta came from. That I didn't focus like for this today. That's not where I'm focusing on. It's more really just about kind of the Maya journey about this analysis. And actually, it did pique some other questions. So if I go on, that was where I continued my conversation with Maya. I said, all right, so we did a little bit of that analysis of the Snowflake versus AWS, but now I want you, Maya, to help build out a plan, doing some more analysis on this data. And we came up with this three-phase plan where we just wanted to do just general trend analysis of Lyft versus Uber. But then we also wanted to do a little bit more numeric extraction and trend analysis, and then leading up to forecasting and predictive analytics. Maya helped me with all of that. All of this was done also in minutes. But if you look at the trend analysis insights that Maya was able to extract, again, I'm not going to go too deep, but I'm going to pick out some of the things that I thought were of interest. But yeah, this is that report of just the trend analysis, okay? You need questions answered, quarters covered, okay? So some really interesting things. It does kind of highlight, once again, how the AWS coverage was a little bit better. But you're seeing here, we're going into like the Lyft growth deceleration path, um, comparative analysis of Lyft versus Uber, reliability for trend analysis. So you kind of see here all the things that Maya did for me in just no time at all. And what I did was I was spending more time just reviewing this as opposed to, building anything. This was the superpower of Maya. Now, notice here, it also mentions the pipelines it built. So here's all of my phased reports, but it mentions here that pipelines 1 and 2 are the ones that help to build or support all of the things that are in that phase 1 report. Moving on to the phase 2, the numeric extraction and trend analysis, this is where you're going to see just some of the other kind of perspective of what it was able to do. So things like numeric extraction, right? Those were those very specific questions like, what was the quarterly earnings? What were these numbers? And that's what you're seeing here. These are the numbers that we're able to extract, comparing Lyft versus Uber. One of the really cool things that I didn't know until doing this work is just how much bigger Uber is to Lyft. And it's very obvious when you start to look and analyze these financial reports. But, Maya was really able to bubble this up really easily. Even went down into that kind of comparison Cortex and AWS, went into data quality assessments, right? Talking a little bit about some of the challenges. But I didn't even have to worry about these challenges. Maya was able to sort it out for me. Summarize some key findings, okay? And the documentation around how it did everything, okay? Now, this was really interesting, going into the forecasting. As I was looking at this forecasting report that Maya generated for me, I gravitated to something here. I'm going to go straight to it. The year-over-year growth rate forecast, okay? Now, with the AWS native method, notice here, the average growth being about 31%, the Q3 2025 forecast being 108%, 142 for Q4, but the Snowflake Cortex related data was double that. You see that? That just jumped out at me. That was like, whoa, what's going on here? This does not pass my sniff test, if that makes sense, right? So that's where I actually said to Maya, picking this out, why are the Lyft year-over-year growth forecasts twice as high, with when comparing the two? Can you compare some of these extracted metrics to see if we can correlate to why do we have this disconnect, okay? So what was really interesting there is that that's led into a phase 4 analysis, and that's what this report goes to. Now, I'm going to summarize this for you so that you don't have to read all of it, but it's all documented really well in here. It's not about, again, not about one being better than the other. It was a really interesting and fascinating thing. But it was really about, this is really more about that natural language and what I actually asked of Maya. But it was the different metrics being extracted when it was doing the AWS native. It was extracting operational metrics, but when it was doing snowflakes, it was extracting EBITDA, which is more about profitability. Okay. And so the key here that Maya was helped me to analyze and broke it down in here was that not that one was right and the other was wrong. It was really about just not comparing the same type of growth metric. Because with Lyft in particular, what they did was they spent, and what I learned from looking at this, they spent a lot of time, especially in 2024, building out their platform. They had a lot of operational costs building out their platform. But now that their platform is kind of in a stable state, they're not investing more in that. And as they add more riders, as their company grows, there's less cost to that. And so their profitability is going to be higher for that reason. And that's kind of the gist of where these differences were. Okay. Um, and so you kind of see here some of the recommendations, like don't average year-over-year growth rate across different metrics. Break it down to specific metrics, things along those lines, right? So that was some of the eye-opening things, right? And so it's not that I came down like this is a little bit of unfinished work, but it was really more of a story because I wanted to show a few different things. And hopefully you're picking that up as I talked today about just what AI in a data pipeline using Matillion looks like, how Maya can augment a data engineer with these more advanced data pipelines. As you can see, this is definitely a bit more, elegant than, more traditional, let's say, Medallion, bronze, silver, gold, or Data Vault, or, SCD, all traditional things that Maya does really well. But you're seeing here just some of the other things that Maya can do. When it's saving you time for developing, it really just frees you up to start to actually look at the data and think about, what it is that you're doing, right? So just going back here to what Maya was able to do, it broke it down to saying, hey, here are differences, was about gross bookings versus net revenue. But as I summarized, neither model was wrong. It was really just about looking at the different metrics in a different light and just being able to be more prescriptive about what exactly is that you're trying to analyze. What are those, the forecasting metrics that you're wanting to, you know, look at. So some of the key takeaways, kind of going back to why I shared this story with you all, is that I wanted you to see what it looks like to do RAG at scale, right? It's a data pipeline challenge that data teams today are trying to tackle as AI is now in everyone's mind, because you saw what that looks like from a Matillion lens. How AI agents such as Maya can help to accelerate your development, going from days and weeks to minutes and hours. Exactly my use case. And then finally, or not finally, that collaboration with AI really helped me to build deeper insights. I freed up so much time that I was able to just continue that collaboration. And what I've kind of shown here today is what that future of data engineering is going to look like. It's really that collaborative, play with an agentic AI like Maya, helping to accelerate your data engineering, but also go deeper and just get better insights.